Factoring. Call me silly, but I enjoy factoring. Okay. You can call me silly, just don't call me late for dinner. Okay. All right, let's talk some vocab. Factors are just numbers you multiply together to get another number. So, like 2 times 3 is 6, so 2 and 3 are both factors of 6. The other factors of 6 could be 1 and 6. So, list the factors of 12. Let me move over here. I always start with 1 when I list the factors. So, we could say like 1 times 12. Well, if it starts writing. So 1 and 12, and then I just build from there. Does 2 go into 12? Yeah. 2 times 6. Does 3 go into 12? Yeah. 3 times 4. And then the next number would be 4. We already have that accounted for. So once you close the gap between your two factors, then you're done. Right? 3 and 4, because you don't need to repeat 4 times 3, 6 times 2, 12 times 1. We already have the factors there. So let's try the factors of 30. Well, I know 1 goes in there. 1's a factor of everything. So 1 times 30. Does 2 go in there? Yeah, it's even. So 2 times 15, all right. Does 3 go in there? Yeah. 3 times 10, okay, all right. Does 4 go in there? No, it doesn't. It doesn't. No. Does 5 go in there? Yeah, 5 times 6. And again, now we've got the numbers that are right next to each other, 5 and 6. We know there are no other factors. We're not getting into decimal factors here because those aren't technically considered factors. Let's see if, okay, there that is. So common factors, obviously, you could probably figure this out, are two things that they have in common. So thinking about 12 and 30, if we said, oh, what are some common factors? It's like, what are factors of 12 and 30? So I think that's our next question here. Common factors of 12 and 30. Well, I see they both have 1. And 1's a factor of everything, so that would always be a common factor. I see they both have a 2 and a 3. 2, 3. This one has a 4, that one doesn't. This one has a 6, and that one does. And that's it. 4 and 12 don't go into 30. The greatest common factor is the largest thing they have in common. So out of the ones we just listed, 6 would be the greatest common factor. And that's pretty important to be able to find. You're going to have to find the greatest common factor quite a bit. So it is the largest thing that they share. Find the greatest common factor of the numbers slash monomials. So looking at 6x squared and 5x squared, I always say look at the regular numbers first. 6 and 5, what's the largest thing that goes into 6 and 5? Just 1. That's the only thing they have in common. Now look at the x squareds. They both have x squared, so that's a factor. So we'd say 1x squared, but we'd clean that up and just say x squared. 15y to the third and negative 20y. Looking at the numbers, 15 and negative 20. So it doesn't matter that it's negative, just think of 15 and 20. What number goes into both of those? 5, right? 5's the largest number that goes in both. Now this one has y to the third, which is y times y times y. And this one just has y to the first, which is just y. So they have one y in common, right? So you gotta go with the lowest exponent on the variables that they both have. So all we can say is 5y to the first power, which is 5y. Over yonder, let's look at 4 and 5. Largest thing they have in common is 1. X to the second and y to the third. They're different variables, so they don't have anything in common. So our greatest common factor would just be 1, and that's okay. That happens. So you can never say like there's nothing in common. They always have 1 in common. All right, one more of these. 8a squared and 28. Now 28 doesn't even have an a on it, so they're not going to have an a in common. So really we just need to look at 8 and 28. So like 2 goes into both of them, sure, but also 4. So 4 would be the greatest common factor here. And when we get to factoring trinomials, the first step is always to look for a greatest common factor. So you gotta be able to do this. Factoring by the greatest common factor. Step one, find the greatest common factor, and then divide each term by the GCF. So we'll see what we're talking about here. We'll see. So our example is 15x to the third minus 6x squared plus 21x. So just look at the numbers first. I have 15, 6, and 21. It has to go into every number for it to be a common factor. So 3 goes into all three of these terms. Now let's look at the x's. We have x to the third, x to the second, and x to the first. So they all have at least x to the first. There's our greatest common factor, 3x. So like it says over here, for step 2, divide each term by the GCF. So don't write what I'm about to write. But really what we're doing is 15x to the third divided by 3x minus 6x to the second divided by 3x plus 21x divided by 3x. That's all we're doing here. But I kind of like to think of it like a puzzle. Like I'm saying 3x times something will give me 15x to the third. So 3 times 5 will give me 15. I have x to the first, I need x to the third, so I need 2 more x's. So it'd be 5x squared, which that's what we get here. 15 divided by 3 is 5. Your properties of exponents state that when you divide, you subtract the exponents. 3 minus 1 will give you 2. Okay. So again, let's see what's missing. 3 times what would give me negative 6? Well, that's negative 2. I have x, I need x squared, so we need another x there. And then 3 times what would give me positive 21? Well, that's positive 7. And we already have the x, so we don't need any more x's. So this would be our final factored answer. So you always want to check the stuff in the parentheses can have no common factors left except for 1. Right? And nothing goes into 5, 2, and 7 except for 1. So we're all good on that. So let's try this out. Why don't you try some of these, pause it, and I'll go over them so you can actually test out your skills. 4x squared and 6x, their greatest common factor would be 2x. 2x times 2x would give me the 4x squared, and 2x times 3 would give me that 6x. Now, if you ever want to check your answer, you could always distribute that 2x to both of them, and it'll come back out to that. So that's one way you can check your final answers. Number 6, 3x minus 6. 3 and 6, 3 goes into both of them. 3 times x would give me 3x, and 3 times negative 2 gives you that negative 6. 10n to the third minus 2n plus 5. They don't have anything in common. So you could factor out a 1. But there's no point in factoring out the 1. You're not getting anywhere by factoring out the 1. So you would just say this one isn't factorable anymore. So we'll say not factorable. Right? Because technically you could always factor out a 1, but it's not going to advance you at all. All right, last one, number 8. 9h to the 8th plus 18h to the third minus 6h squared. There we go, there's the extend page. The old extend page. So 9, 18, and 6, the greatest common factor would be 3. We have h to the 8th, h to the third, and h to the second. So they all have at least h to the second. So that would be our greatest common factor. So again, we're just filling in some blanks here with what's missing. 3 times what would give me 9? It's 3 times 3. I have h to the second. I need h to the 8th. So we need h to the 6th, right? 3h squared times 3h to the 6th gives us 9h to the 8th. 3 times what would give us that 18? Well, that's 6. I have h to the 2nd, I need h to the 3rd, so we need one more h. 3 times negative 2 would give us negative 6, and then h squared, we don't need any more h's. So this would be our final answer there. Okay, now we're going to factor some trinomials. You can use factoring to write a trinomial as a product of binomials. So binomials, think of bicycle, there's 2 wheels on it. Tricycle, tri has 3, triangle has 3. So you're going to have something, your final answer is going to say something like this: x plus 3 times x plus 4, or something similar to that. Now, you might remember the old FOIL back in the day, first, outer, inner, last. Let me just show you on this one kind of how this works out. If we multiply the first terms, we get x squared. Outermost terms would give us 4x. Innermost terms are 3x. And the last terms would give us 12. So if we combine our x's in the middle, we'd have x squared plus 7x plus 12. Now we're going to be given this, and we have to turn it into the binomials. So kind of look at how we got these numbers. The last number, 12, is what you get when you multiply the 3 and the 4, right? Also, 7 is what you get when you add 3 and 4. So we're always looking for factors of the last number, they multiply to the last number, and they add up to the middle. It's a little dicier when you have subtraction at the end, which we'll get to right now. So if we look at the last number, we have 6. The factors of 6 are 1 and 6, or 2 and 3. Now, because they multiply to negative 6, you have to think, are these going to be 2 positive numbers, 2 negative numbers, or one of each? What's the only way you can multiply to a negative? It's a positive times a negative. So we'll say x plus something times x minus something. Now, when the last term is negative, they're actually going to be this far apart. So we're looking for a set that is 1 apart from each other, which has to be 2 and 3. Now, technically, when we're done, they will add up to positive 1, because that's going to determine which one goes with the plus and which one goes with the minus. So the only way you're going to get them to add up to positive 1 would be positive 3 and negative 2. So the way I always have to try to remember it is, first of all, I look at the last number, it's minus, I know it's one of each. And then the bigger number always goes with the first symbol. So in this case, the bigger number would go with the plus. If you look at number 10, it ends in minus. So I know it has to be 1 plus, 1 minus. But my first symbol is negative. So I know my big number is going to have to go with the minus. That's the only way they can add up to negative 12. So thinking of the factors of 28, we have 1 and 28, 2 and 14, 4 and 7. And because it ends in minus, we need them to be 12 apart initially, which would be 2 and 14. So to make them add up to negative 12, they'd have to be negative 14 and positive 2. It's pretty tricky when you got the minus at the end. You're always going to look for a greatest common factor first, though. And these ones, this doesn't have any because your first term is 1x squared. Your last term doesn't even have any x's, so there's no common factor. So now we can look at the last number. I see it's negative, which means it has to be one of each, 1 plus, 1 minus. If they're going to add up to negative 2, we're looking for a set that's 2 apart. Now, if you're thinking of numbers that multiply to 48, and you're like, you find 2 that are 2 apart, then those are your numbers. But you might not be able to get them right away. So that's why it's important to list out the factors. So starting at 1 and 48, are those 2 apart? No. 2 and 24, nope. 3 and 16, ooh, we're getting closer. 4 and 12, okay. And 6 and 8, 6 and 8, those are the ones that are 2 apart. So it'd have to be minus 8 and plus 6, because that's the only combination that can add up to negative 2 and multiply to negative 48. Number 12. Now these ones, again, are the factors of 48. We just listed them. But if you look, now it ends in a plus. Anytime it ends with plus, they have to both be either both positive or both negative. So that's where you could look at the first sign. And you're seeing that they're going to add up to positive 14, so they'd have to both be positive. So positive times a positive gives you a positive and adds up to a positive. So factors of 48 that add up to 14 would be 6 and 8. X plus 6, x plus 8. If you ever have extra time on a test or quiz, FOIL that out and make sure you get the original question, which you would here. It'd be x squared plus 8x plus 6x plus 48. And then you combine your x's, x squared plus 14x plus 48. It's the only combination that'll get you there. Okay? 14, anytime your first term is negative, we have to factor out that negative. So we're going to factor out negative 1, which just makes everything the opposite inside. So now it'll be positive b squared, it'll be minus 2b, and it'll be plus 1. So that negative kind of hangs out until the end. Now look here, it ends in plus, so they better both be the same symbol. They're either both pluses or both minus. If they add up to negative 2, they'd have to both be minus. B minus, B minus. What are the only numbers that multiply to 1? 1 and 1. So for today, if you left this, you'd be gold, Tony boy. But if you look, they're both x v minus 1. We can clean that up a little bit. If I said, oh, you have x times x for your final answer, you'd be like, that's x squared. So we're going to rewrite this as v minus 1 squared. The negative was factored out earlier. So again, if the first term is negative, always factor out a negative. All right, we look at our last number, it's minus, which means we have to have one positive and one negative. We're looking for a set that multiplies to 18 and are 3 apart. If they add up to positive 3, that means my big number is going with a plus. So 18, we have 1 times 18, 2 times 9, or 3 times 6. Which set is 3 apart from each other? The 3 and the 6. So to get it to add up to positive 3, it has to be plus 6 minus 3. Box it up, baby! Woo! 2 more. Oh my goodness. They multiply to positive 3. So they have to both be the same sign. Either both plus or both minus. If they're going to add up to positive 2, they'd have to both be plus. Now the only factors of 3 are 1 and 3. But remember, they have to add up to the middle term. Is 1 plus 3 2? No, it isn't. Ooh, this one's not factorable. I tried to trick you, but I couldn't. Not factorable. Now, if that plus 3 at the end was minus 3, then it would be factorable because the factors of 3 could be 2 apart. But it wasn't. It wasn't. All right. 2p squared minus 8p plus 8. Is there a common factor? Yeah. They're all divisible by 2. So we can factor out the 2. 2 times p squared, 2 times negative 4p, and 2 times 4. Okay, now this 2, we can kind of ignore on the outside. Don't worry about that. That'll just be part of our final answer. So now if we look at the inside, I see it ends in positive 4. They need to both be the same sign. If they add up to negative 4, that means they have to both be negative. P minus, P minus. Factors of 4 include 1 and 4, or 2 and 2, which set adds up to 4, the 2 and the 2. Hey, it's the same thing in parentheses. Let's write it as p minus 2 squared. So we have the 2 on the outside, and then p minus 2 squared. Lots of 2's on that one. Lots of 2's. Hey, day 1 in the books.